Hi, I'm Miss Julie, and I got some science experiments for you today. I work at the Tinley Park Library in the Youth Service Department, and normally a program like this would be done at the library, but since we're all at home, I decided to recruit a kid to help me. This is my daughter, Ashley. She's in 5th grade. She has not done any of these science experiments yet, at least to my knowledge, so they will all be new to her. I love doing science experiments. As my daughter knows, I always make them do the science fair experiments in school. They don't seem to like all the work that's attached, but I think they do like doing the actual experiments, so they can be fun. We are going to do 4 today. I want to let you know a couple things is that I tried several ahead of time that didn't work, and that's part of the process of doing science experiments. I don't know why they didn't work because they looked easy in the book, but when I try to do them, something went wrong. And that's usually because of something called a variable. I must have done something that was not intended to be in the science experiment. Maybe I had a different kind of equipment, or I didn't have the right tools. Something went wrong, and that's okay too. For our first experiment, we're going to do one that's pretty simple, and it's a color experiment. We have milk in here, no measured amount, just enough to fill the plate or an estimate. Dish soap, regular dish soap, some food dye, and then some Q-tips. So I'm gonna have my helper Ashley here pour the milk into the plate, just enough to fill it without overflowing. As she pours ever so carefully. We are using whole milk. I did this experiment to test it out earlier using 1% milk, so I'm trying to see if there's a difference even with that. We're gonna add the food dye. For the best results, I recommend putting the dye next to each other in a clump. So they're kind of touching, and that'll give the best effect. But of course, if you play around with this, you can do whatever you want, and you can move the colors all around. But I think it makes a really nice effect if you put them close together. Like, so they're touching each other.
Okay.
Let's
Almost done.
I know. No, it looks good. All right, and let's see, how about a little more, and maybe try to fill in that spot right there so that they're pretty close to each other. And let's see. Okay.
Okay.
All right.
Now,
Can you put like maybe another color like right in here, like
middle milk?
yeah, so that they're kind of all connected. Again, this is just to get the best effect. Okay, well, let's give it a shot. All right, go ahead and dip the Q-tip in the dish soap and give it a, now when you do it, all I want you to do is do like a drop right on there, and you can like swirl it like this. Instead of moving it around, just go like this and see what happens. You got quite a bit on there, make sure it's covered.
Yeah.
Okay, put it right in the heart of your, so it's like in the middle of one, and watch it go. Let's see what happens.
Whoa.
There we go. So this one, the whole milk was recommended, and it did make it a little bit more of impact in the beginning. So all that's happening here is the fat particles, or the dish soap is reacting with the fat particles in the water, and the dish soap is pushing them to the side, taking the colors with them, and it's still moving. This one's a lot of fun with a lot of different colors, and just kind of swirl it around, and you can make different patterns. Easy to do. Just please be sure to check with your parents first if you can take the milk. Making sure that you don't take the last of it, and then all of these products should be available in your cabinet. All right, good job. For our next experiment, I got it straight out of the library book. It's called Experiments with Rulers. This is an interesting one. It's called Balancing Unequal Weights. And when all you need for this one is something to have as the point to balance on. The book recommended having an eraser, but I didn't have one. So I found a block, and then I'm just gonna balance it, and a ruler is 12 inches, so the middle point should be 6. So I'm gonna put the 6, sorry, you put the 6 right on there to balance. Okay, what does this look like to you? What comes to mind when you see this?
It's balanced.
But what comes to mind? Like, what would you find at a park that it would look like?
A seesaw?
Right, a seesaw, a teeter-totter, whatever you call it. What typically happens when you go on a teeter-totter with someone who's your age? Is the balance pretty well?
Usually I'm at the top.
Okay, why is that?
It's because I'm light.
Ah, so the heavy person stays at the bottom and the light person will be at the top. Here, so grab a couple of pennies. Well, actually, you be you. So add yourself here.
Okay.
So you said you're the heavier one, right?
No,
Oh, the lighter one, sorry.
in the air.
Right, okay, so go ahead and put yours there. Go ahead, put it on. I'll do it. Let's say that we were balanced, I'm sorry. Okay, so if someone got on and they were pretty much the same weight as you, you could do a teeter-totter because you can balance. You add on now, so now we're switching it because I'm keeping you here, and someone who's heavier. So you can see that doesn't work and you kind of fly up on top.
Yeah.
So let's say, is there a way to balance this if someone was heavier? Could you do it?
Yes.
What do you do?
Well, it wouldn't, like,
What
to
do you,
not touch the ground or to be exactly.
to be balanced, what would you, is there a way to balance when you have 2 pennies on one side and 1 penny on the other? Is there a way to balance this?
Yeah.
How?
Well, you could just, like, move
Yep.
this one a little bit up, and then you can, like, wait, and then maybe it'll stay.
Okay, and how would you move it up on this? Is there a way, do you think you move it up?
I don't know, I'm just thinking of seesaw.
You're right though. Sometimes when you go to the park and you see a seesaw, I see someone over here and then someone gets off the seat and moves closer this way. So let's see if that works. We can slide it. Slide it a little closer this way and see if it works. I'm going to hold it until you think it's balanced. Keep going. Okay, so it worked. As you move closer to, this is the science word of the fulcrum, which is the point it's balancing on, this becomes closer, you're actually putting more weight on this side and it's helping to balance. So that would be like a kid, but let's say you had your dad come on and he's a quarter and a nickel, and you're still over here. Do you think we can make that work?
Yeah.
Let's give it a shot. Because normally when there's a kid and there's a parent, it definitely goes whoop, like that.
Yep.
So let's see if we can get it to balance. Where do you think it's going to end up? What's your guess?
Right there.
Keep going. I'm going to hold it until you think it's ready.
Yay.
So when you have a very light weight and you have a heavy weight, look how close it is to the fulcrum. However, it can balance. Now this is actually found in everyday usage. When you take a look at, let me find my page, here in a crane, you can see here how there's a very heavy object getting pulled, and look at, that's the counterweight, that's the weight on the back. So for it to pull it, it has to slide it closer and closer so that this weight can kind of help balance it. So this is actually used in technology of a crane. So you can impress your friends and your family with, you can get this to balance a penny on one side and a nickel and a quarter on the other. Okay, for our next science experiment, this one is called Science or Magic. This one's pretty neat. It's an optical illusion. We are going to fill this beaker here with regular water, and we're going to see what happens with these arrows. So I'm going to ask Ashley to go right here and to get eye level with here so that you can see, kind of squat down and see if you can see the arrows. Let me know when I cover one of the arrows. Okay, and tell me what you see. By the way, this is just water. Or is it? With water.
Okay, cover first arrow.
And what happened?
It's still there.
But what happened?
It flipped.
What do you mean?
It stopped facing the other direction.
So the arrows are now facing opposite directions?
Yeah.
Oh, so I'm going to keep going. Let me know on the other, what happened to the other one.
The other one now flipped.
Okay. Why did it flip? Do you know?
Because the water reflection And I don't want to go back into science.
This is a demonstration of water refraction. I'm going to have my assistant now try to show you how this looks. So come on over here, and our cameraman over here is going to squat down. And can you just give us a sign? She's going to pour slow and kind of give us a sign when one, well, I'll go behind you. See, one arrow takes effect. Go ahead. Go slow. Okay, keep going and stop. You can see that one arrow flip, the one that's covered with water, flip direction. And what do you think is going to happen when we keep filling? Aha, they both flip direction. This one's a cool experiment because it looks like magic, but it's called water refraction. The simplest definition of refraction is the change of waves passing from one medium to another. So when light travels from air into water, it slows down, causing it to change direction slightly. This is called water refraction. An example of refraction of light is when you see a rainbow outside. That is the light changing and a refraction is taking place, and that's when we see all the colors. So this is a fun one to make it seem like you know how to do magic. All right, on to our last experiment. All right, we are back for our fourth and final experiment, and we are going to be making a volcano. And here you can see a picture of the book. I use the electronic version, but this book is found at the library, so when it opens, you can grab it off the shelf. It tells you step by step what you need to make this volcano. We laid out all of our ingredients here. They asked for a 12-ounce bottle, but I found a 10-ounce bottle, so we're just kind of modified a little bit. I put some brown paper around it so it looks more like a volcano. Some other stuff we have here is a pan so that we can catch our lava when it explodes. I went ahead and pre-cut some strips of paper, which we'll go ahead and put around here, which we'll do in a little bit. The tape is for that. So the parts that we need for our volcano is we have 8 ounces of warm water, not hot, just warm, 2 ounces of vinegar. Dish soap calls for 6 drops of dish soap, but we don't have a dropper, so Ashley's gonna have to be careful when she drops it in one at a time, do the best she can. We have 2 tablespoons of baking soda. We also have some food dye, which you can use whatever colors you want. We're using yellow and red. Some straw will be needing to stir, and then it also calls for a funnel, which we didn't have, but Ashley went ahead and made one out of paper. All right, so we are ready to begin. So this is our bottle here, which we're just putting right here on our pan, and we're going to be taping some little strips of paper that I cut. They're obviously uneven, you can see that, and that's okay. We're just gonna tape them just like this at the top. And it's just part of the experience of making it look more like a volcano. So I'm gonna give you some and we'll start taping them around. This part is not necessary. It's just kind of make it more fun. So we'll do this quickly, add a few layers. This represents eventually some of the lava and how a volcano would look. Okay, how about one more on your side? How about a yellow? Put it right over here. Okay, now we obviously could do more and we can do better layers and stuff, but I think this is good enough for now. All right, so we have our volcano ready to go. So let's go ahead and get this activated. Is it better now?
Yes, I need a better side.
Okay. So the first step, let's see, now that we got it moving, is we are going to add our baking soda into the volcano with the funnel. So we have two tablespoons of baking soda, which is pre-measured. Dump it right in, make sure it all gets in there.
You can spill any.
We're going to add a few drops of coloring, so this is up to you on what you want to make it, how dark you want to make the lava. Just a few drops of each would work. I still say add some glitter if you want. I think that'd be cool. Okay, so you added the red, and now you're gonna add what?
There's some yellow to make it orange.
Okay, sounds good.
But I don't know if that one's pink or not. So
I think it's red. Well, it'll look good. All right, now we have our 8 ounces of warm water. We just heated it in the microwave, but it's been cooling now, so it's not hot at all. It's just kind of lukewarm. Okay, looking good. Now when she filled this, it really is almost all the way up to the top. It's pretty much like right here, which is good. We want that. So using our straw as a stirrer, we are going to mix it all up. Now we are going to add the dish soap, 6 drops. Now this can be a little tricky for us, so we'll do the best we can. 6 drops. Yeah, it kind of runs together. So we'll see. We'll see how it turns out. So if you have a dropper at home, I'd recommend that. I think the dropper would make it more precise. Stir just a little bit, nice and slow.
oh, nice and slow.
Sorry. And once you think that's pretty mixed, we are ready to add our vinegar. So we have 2 ounces of vinegar. And here we go. We should have our...
Oh, it's exploding from this way too.
Keep adding. So we have our volcano. It erupted.
Oh no.
And unfortunately, we had a piece of the paper hanging over the side, so it went on the floor, which was the whole idea of the pan. But hey, it's fun. It's fun to make things explode. Now, a lot of you probably already know that if you add baking soda with vinegar, you're going to get the bubbles and the explosion, which is what this did. You can definitely add more, make a bigger explosion. You can play around with it with different things to add. But it's always fun to make things explode. All right, well, we hope you had fun. Thank you, Ashley, for helping us with the science experiments. Please go ahead and try these at home. Just hit pause if you have to, if you kind of get stuck and don't remember what to do, because you can always go back and rewind it if you have to watch it again. All of these, though, are things hopefully you can find around the house. Have fun. Bye.